the name of Almighty God, I am Asas Sankosha, and today I want to talk about the size-based population balance interface. The size-based population balance interface, found in the precipitation and crystallization group of the chemical species transport branch, is used to model a size distribution of particles, droplets, or bubbles. The interface supports simulation of the space and time-dependent size distribution and mass transport by convection and diffusion. The interface can be used in 0 dimension, 1 dimension, 2 dimension, and 3 dimensions, as well as for symmetric components in 1 dimension and 2 dimensions. The dependent variables are the population number, density of each size interval, accounting for interval length and 1 per quadratic meter. The minimum number of dependent variable is 5. Settings section. The label is the default physics interface name. The name is used primarily as a scope prefix for variables defined by the physics interface. Refer to such physics interface variables with expressions using the pattern named as variable name in order to distinguish between variables belonging to different physics interfaces. The name string must be unique. Only letters, numbers, and underscores are permitted in the name field. The first character must be a letter. The default name for the physics interface in the first model is PBSB. Now I want to go through the domain selection. Select the domains of the model that population balance model should be applied to. Out of plane thickness for 2 dimensional components, the text field default value is 1 meter. Defines the parameter for the thickness of the geometry perpendicular to the 2 dimensional and cross-sectional area. Both constant and varying thicknesses are supported. Now I want to go through the cross-sectional area. For 1 dimension components, the text field default value is 1 square meter. Defines the parameters for the cross-sectional area perpendicular to 1 dimension component. Both constant and varying areas are supported. Constraint stabilization. To display this section, click the Show button and select stabilization. Two consistent stabilization methods are available: streamline diffusion and crossfire diffusion. Both are active by default. When the streamline diffusion checkbox is selected, a weak artificial diffusion in the streamline direction is added to the transport equation when the crossfire diffusion checkbox is selected. A weak diffusive term, also go on to the streamline direction that reduces spurious oscillation, is added. The consistent stabilization methods don't perturb the original transport equation. Now I want to go through the inconsistent stabilization. To display this section, click the Show button and select stabilization. One inconsistent stabilization method is available: isotropic diffusion. Isotropic diffusion can affect the accuracy of the original problem, and the isotropic diffusion checkbox is not selected by default. For under-resolved problems, this option can be used to get a good initial guess. And now I want to go through the advanced settings section. To display the section, click the Show button and select advanced physics option. Select non-conservative or conservative for the material balance from list. A non-conservative is selected by default and does usually not need to be changed. At particle properties, the particle properties section is used to specify properties of the particles in the population, intervalue or expression for the density and the molar mass in the particle density and particle molar mass fields. Select the particle shape from the particle shape list. Select spherical for spherical particles or cubic for cubic particles. For user defined, specify an area shape factor and a volume shape factor in the corresponding fields. These properties are used for calculating additional variables such as particle volume and when using certain predefined nucleation and growth rate models. Now I'm going to go through the size intervals. Select the size discretization approach from the discretization list. Select linear. To use a linear discretization approach for a non-linear discretization, you can select logarithmic or geometric. For all options, enter the number of size intervals to model in the number of intervals field, and the smallest and the largest size to model in the minimum size maximum size field. For the geometric option, also enter finite constant in the geometric constant field that controls the size interval wide. Now I want to go to the nucleation. Select an option from the nucleation rate list to add a particle source to the smallest size interval. Three different options are available: user defined, homogeneous expression, and homogeneous nucleation. Now I want to go through the growth and dissolution. Select an option from the list to apply a growth and dissolution rate to all intervals. The options that are available are user defined and transport control. Select user defined to enter A value expression. When this option is selected, the text field also accepts an expression written as a function of the particle size pop L when solving pop L and will be replaced by the discretized particles size. Separate text fields are available for the growth and dissolution. A positive growth rate results in particles becoming larger, while a positive dissolution rate results in the particle becoming smaller. Set spot control to define a growth and dissolution rate that is limited by the transport of dissolved species. Aggregation. Select the include checkbox to include aggregation. When selected, enter an aggregation kernel in the aggregation kernel field. The field supports expressions that are functions of two colliding particle size, pop LJ and pop LK. Breakage. Select the include checkbox to include breakage. When selected, enter a breakage rate constant and an average number of particles resulting from the breakage in the breakage rate constant and average number of resulting particle fields respectively. Dissolve the species properties section. This section is only visible when additional information is requested by the growth or nucleation section. This is when homogeneous nucleation is selected in the nucleation section of transport control is selected in the growth section. Enter a value exposure in the concentration, equilibrium concentration, and diffusion coefficient fields. Now I want to go through the discretization. To display all settings available in this section, click the Show button and select Advanced Physics option. The Compute Boundary Fluxes checkbox is activated by the default so that Constant Multiphysics computes the predefined accurate boundary flux variables, storing accurate boundary fluxes from each boundary into the adjacent domain. If the checkbox is clear, the Constant Multiphysics software instead computes the flux variables from the dependent variables using extrapolation, which is less accurate in post-processing results but doesn't create extra dependent variables on the boundaries for the fluxes. The apply smoothing in the boundary fluxes checkbox is available. If the previous checkbox is selected, the smooth can provide a more well-behaved flux value close singularities. For details about the boundary fluxes settings, see computing accurate fluxes in the constant multiphysics reference manual. The value type when using splitting of complex variables should in most pure mass transfer problems be set to real, which is the default. It makes sure that the dependent variable doesn't get affected by small imaginary contributions which can occur, for example, when combining a time-dependent or sectional study with a frequency domain study. For more information, see splitting complex value variables in the constant multiphysics reference manual. Domain boundary and pairing nodes for the size-based population balance interface. The interface has the following domain boundary and pairing nodes listed in alphabetic order available from the Physics Reborn toolbar Windows users, Physics context menu for Macintosh or Linux users, or by right-clicking to access the context menu for all users. To add a node, go to the Physics toolbar. No matter what operating system you are using, subnodes are available by clicking the parent node and selecting it from the attributes menu. The different sections are additional source fluid, inflow, initial values, no flux, number density, outflow. For axis symmetric component complex composite, multiphysics takes the axial symmetry boundaries at r is equal to 0 into account and automatically adds an axial symmetry node that is valid on boundaries representing the symmetry axis. In the constant multiphysics reference manual, see table 2-4 for links to common sections and table 2-5 for common feature nodes. You can also search for information, press F1 to open the help window or control plus F1 to open the documentation window. So thank you so much for watching my tutorial video until the end. Also, you can find the console file from github.com/masterscript. Today is 17th of May 2026. Time is 8:10 a.m.